My name is Mark Urban Lorraine. I'm the host of this session. I'm the SSE secretary, and it's my pleasure to introduce our next speaker, Massimo Teodorini, who is an astrophysicist from North Italy. His PhD in astronomy from Bologna University is with a specialization in stellar physics. He has been carrying out research on eruptive phenomena in astrophysics and is an expert in photometric and spectroscopic observational techniques. He's been working as a researcher at the INAF Naples Astronomical Observatory and at the INAF Radioastronomic Observatory in Mendocino. Being experienced both in optical and radio astronomy, he has carried out research on extrasolar planets and the search for extraterrestrial intelligence. He is presently a research affiliate in the Galileo project. And so with that, I'd like to turn over the stage to Dr. Teodorini. Thank you.
Thank you very much. Well, my presentation will be an astronomy presentation. And I like to start with a nice photo of the Webb Space Telescope, because the Webb Space Telescope, especially its infrared capability, might help us to obtain important results in what I am about to discuss about. Anomalies in astronomy, there are several examples. We know a lot in astronomy. We know how stellar evolution works. We have a good confrontation between observation and theory. So our science is working well. But there are some things that are still lacking in our knowledge, okay? So there are some things, I can make some examples, but I will not discuss these examples because I will want to focus on three particular aspects. There are some things that don't work. For instance, supernova 1987A exploded as a blue supergiant. This cannot happen. It should be a red supergiant. This is something that must be revised. There are fast radio bursts that have been discovered, especially in the last 10 years in several observatories of the world, and as well as gamma ray bursts. In both cases, this kind of burst can be explained as astrophysical objects, with no doubts, but in other cases, they cannot be explained so easily. It's not so easy to say this is a particular kind of magnet or neutron star. Okay, you can build all the mathematical models, but what we need is data, and data must be very strong. Only when we have strong data, we can build up mathematical models over them. Tabby star, for instance, a strange star that all of a sudden is decreasing in luminosity with a secular decrease of some months. It's very strange. And clearly, several conventional explanation, logical explanation have been found, which are logical, but we're not sure if it's really, that logic is correspond to realism. Strange bubble-like planetary nebulae without nuclear objects inside, like a white dwarf, for instance, or appearing and disappearing stars from the sky. That has been documented by, for instance, the Vasco project and Dr. Beatriz Villarroel and their collaborators. Or Oumuamua, like interstellar objects that everyone tried to explain as a particular kind of comets or asteroids or clouds, but you cannot explain in a conventional way. You can create conventional scenarios that are logical, but being logical doesn't mean always to be the reality of the thing. What I want to speak about in this case is something that we are not sure if we something has been found, but we would like to make a key project. In astronomy, only key project can bring to prominent results. Okay, in this case is to search for particular kind of stars, like G-type stars, like the Sun, for instance, and see if there is an infrared excess. If they are emitting more infrared radiation than they are expected to be. I will explain why we are searching for that. Or anomalous exoplanets or planetoids that show a particular kind of light curve that is not expected by standard planets, or infrared objects which have a very strong proper motion, which are very fast in the sky, letting us think that it's something that is very close to us. So, um, first of all, where are we going to search? This is a research proposal. It's a systematic research proposal to search for some kind of anomalies that could be explained by as technosignature by extraterrestrial civilization. It's a possibility. Okay, why not trying? So we would work on stars of solar spectral type nearby, very close. So something that is burning hydrogen very stably in the main sequence, and that are very stable objects, very few flares, and no emission of envelopes or something like that. And they have a very long lifetime. So there is all the time to develop civilization, more than one civilization, clearly, several cycles of civilization. They could host planets like Earth at habitability zone in the vicinity of our system. We have already several hundred of stars, several which could host civilization. And we would concentrate our attention on globular clusters, which are very old cluster of stars which contain up to 1 million stars, among which also G-type stars, in addition to giant stars and brown dwarfs. So they are very old. So there is a high possibility to find something. And so we would like to concentrate the attention on stars of like the Sun. Okay, what happens if stars like the Sun behave in a completely anomalous way? Where is the anomaly that we are expecting? I will tell you very often, very soon. Before telling this, I anticipate the old theory, which is reasonable, about Kardashev civilization, which is the split in three types: type 1, type 2, and type 3, according to the capability to develop energy, able to tap the energy of their planet, which we are not yet able to do, able to tap the energy of their star, or able to tap the energy of their galaxy. I will concentrate on type 2, capability of concentrated to use the energy, to tap the energy of their star. Okay, so they are called Dyson sphere. How would they behave? What would we see during our in the case of our observation? We would expect that most probably they would develop around G-type stars, not necessarily only them, maybe also red stars of some kind, but mostly we have to concentrate it on G-type stars because of the specific strategy. We would have something that is wrapping the stars with a technological orbiting objects. The star could be totally covered or partially covered. What we would expect is that the optical radiation of the star would be re-radiated in the infrared due to the effect of reprocessing of radiation of these technological objects that are surrounded in this kind of stars. This can be partial, most probably. This would block from 1 to 10% of the total starlight. And all of this, above all, would give, would produce an more infrared radiation than the one that we would expect from a star of that spectral type. From G type stars, we do not expect the emission or the production of envelopes of gas. For instance, in BE stars, which are giant blue stars of main sequence, we have big circumstellar envelope, or also O stars. We have envelopes around it. There is emission of gas outside. There is a strong mass loss in the case which produce an infrared excess. In the case of G-type stars, we don't expect anything like that because it's a very stable structure, a very stable hydrogen burning. And so what happens if we find an infrared excess in this kind of stars, in stars like the sun? Okay, how to search for this? Well, clearly the Webb Space Telescope would be the ideal telescope because it's a very big aperture, 6.5 meters, because it's concentrated in the infrared, both photometrically and spectroscopically. This means that we can push very far away our search and increase the statistics of our findings, of our possible findings. So we would concentrate on solar type stars in order to detect a possible anomalous infrared excess. Namely, if we have an spectral energy distribution where we have the flux as a function of wavelength, normally for G-type stars, we would have this curve, logarithmic. Instead, we expect that an infrared excess would create in the experimental observed points something like that. What is causing all of this? Clearly not a natural process unless our theory of stellar evolution and stellar structure are completely wrong. I don't think it's completely wrong because I think stellar evolution and theory of stellar structure are correct, mathematically correct, even if something is missing because we wanted to make calculation easier. For instance, we didn't put inside magnetic field. We didn't put electric charge. It would complicate magnetohydrodynamics, would complicate calculations. We considered these factors negligible, and so we made a theory of stellar evolution and stellar structure, which works quite well because it fits with the observation, especially when we see population 2 objects like globular clusters, and it fits the theory. So I trust the theory of stellar evolution and structure, and if I see infrared excess, I start to suspect that this excess is caused by something artificial. Someone in the past, even if with very lack of funding, tried to look into the archive of IRAS, Infrared Space Telescope of the 70s, and tried to monitor more than 11,000 sources, and found that 16 of them could be possible candidates. But this was not a key project. This was something parallel. Instead, we need a key project, especially now that there is an opening to the possibility to find techno-signatures in space. And my wish is that using the Webb Space Telescope, plus other telescopes like Spitzer infrared telescope and big telescopes that we have on ground, optical telescopes, to try to make a key project lasting for 2 or 3 years, observing only these things in order to see if there are techno-signatures in space, searching for this before searching for possible signals in the radio band or in the optical band. I mean, first we would use techno-signatures like a selection criterion in order to concentrate a SETI search, and I will show you how. Another possibility, in addition to infrared excess that we are expecting from Dyson spheres, okay, which is a reasonable theory, very anthropomorphic theory, I would say, but reasonable, okay, it could be possible. We have to look at the way in which objects or planets or planetoids are eclipsing their own stars. Clearly, there is a minimum at eclipse, and this minimum can have a very specific shape according to the size of the object, according to the distance of the eclipsing object from the star, and according to the geometric shape of the objects. It's very interesting because in the past, a French astronomer, Luc Arnauld, who was working at that time, I think he still works there at the Provence Observatory, wanted to make a mathematical modeling, okay, a way to search for artificial structures using optical and infrared telescope, okay, imagining objects, huge objects that are orbiting around this kind of stars, that all together, imagine there are many of these objects, are contributing to create themselves an infrared excess. But not only that, but also particular light curves that mathematically can be simulated like he did, and an object with a very specific geometry that is eclipsing for some time, taking away the light for one part over 1 million, could create a very specific shape in the light curve that we already know how it would be. And so we could compare our mathematical modeling with what we are going to observe. This kind of research could have been made with the Kepler photometric space telescope. I think that not all the data have been analyzed. I think that maybe some of the so-called extrasolar planets which have been discovered using photometric occultation methods might not be planets, but might be artificial planetoids. Okay, so if we have two factors. We have an infrared excess, and we have the search for extraterrestrial technology using, in the first case, the infrared excess that we expect, and in the second case, anomalous light curves. If we united both of them, if we are so lucky to be able to discover both characteristics in some kind of G-type stars, okay, for now, G-type stars, even if they are not the only one that can be inhabited, then we would have a strategy, which I call CSAT, which would help us to steer the SETI project in a very specific way. I'm sorry, this is very war-like example, but it gives the idea, in the sense that we uh, we don't we don't look at the sky with the SETI, with a radio telescope, at random, using an old sky survey. Well, okay, but we have to make a targeted search. How do we target? I'm in my idea, and not only my idea, is that we would target these stars after and only after identifying techno-signatures. We see infrared excess, we see strange light curves, then and only then we aim our telescopes towards this kind of stars to see if there are uh, signals that let us think about a possible intelligence using radio SETI or using optical SETI, searching if there is some kind of laser beam that is outshining the stars that is being observed for some moments. Okay, so in that case, I think the probability to see something would increase very greatly. I spoke about this at International Academy of Astronautics 10 years ago. I discussed about this, and clearly then and only then we would use our standard radio SETI and optical SETI. I've been working on radio SETI when I was searching for extraterrestrial planets, for instance. And unfortunately, apart from strange false alarm, we found nothing in spite of 56 targets that I was using to search for water using the 22 gigahertz water line in these star candidates. So we could use techno-signatures if we find them in order to aim radio and optical to get optical and radio signal, even if I doubt very strongly that anyone in the universe would be on purpose send signals to anyone else. I think that I'm totally with the idea of Stephen Hawking, but it would be possible that some signals might escape from their systems, from their satellites, space station, and so on. So to direct this kind of research, we would search for infrared excess, for partial Dyson spheres, or even almost total Dyson spheres, using infrared capable telescope like a Spitzer telescope and James Webb telescope. We would use Kepler optical telescope or something like it, which a new photometric telescope will be sent, and analyze the light curve that are obtained according to the mathematical model that are being done to find anomalous light curve produced by particular geometries orbiting those stars. Then SETI research, we would use radio SETI and optical SETI. So radio SETI and optical SETI are to be used not blindly, but only after we found techno-signatures, anomalous light curves. We already have mathematical simulations, and if we can compare with something that we really see, especially now that we have a Webb Space Telescope, this would be a great discovery. I published this on peer review journal in the past, and the last part, the second part of my talk, deals about the possibility that intelligent civilization are able to travel inside the galaxy. So I don't want to steal time for the talk, but it's clear that if we don't receive any signal from other civilization, this could be due to the no intelligent civilization exists, or that highly evolved civilization do not communicate anymore using electromagnetic signals. And in case we see some kind of civilizations, some kind of signals, this would be simply a selection effect of some kind of civilization that are similar to us. Okay, this doesn't mean that we found the extraterrestrial intelligence. We found extraterrestrial intelligence by putting our almost black filter in our glasses. Okay, but it would be a great discovery. There is a theory now, and don't discuss too much about this, that in the past already mathematical theory that was treating possible of expansion of interstellar civilization using hydrodynamic equations, called in this case diffusion equations. So treating every civilization like a particle of a gas, so that this calculation shows that this migration flux would develop like a wave that grows like a 1,000th of light year per year, and it would colonize the galaxy in a very short time, so that we would need to add a new parameter to the Drake equation, which can be very easily quantified. I can tell you if you ask questions. I don't want to go there, but there is a justification, a mathematical justification, a canonical justification to the possibility that Earth can be visited, and that because migration is a possibility. Okay, so in this case, imagine that some of those how to say objects that are orbiting around these planets all of a sudden are detached from their planets and sent away, maybe because their star is becoming a red giant, and so they have to escape away. So it's possible in some way that they travel through space for 1,000 million of years in several shapes. They could be artificial huge planetoids, like big or bigger than the moon. They could be container of embryos. They could be container of nano robots made only of artificial intelligence. They could do these kind of things, and migration could be a natural process. Okay, that clearly astronomy can investigate only if we decided to make a key project, systematic project. This is a funny thing. I'm thinking Enrico Fermi was telling, where are they? And they would say, well, we are here. And you say, my apologies, but my arthritis prevents me from turning my head. Great, so we can take your hard yard undisturbed. No, please cure my arthritis. And how do you learn to cure yourself? The point is, you learn to cure yourself means that we have to crash our head against the wall until we understand how to do certain things. For instance, how can we extract negative energy from the vacuum? Is there any trick? Is there any trick in which we can warp space-time for warp drive? There must be, but we have to crash our head. We don't need someone that is telling us how to do. We have to crash our head until we understand. And because this happened probably to many civilizations, even if civilizations are rare. So in the past, SETI found some kind of signals that were not repeated, unfortunately. And the SETI protocol says that if a signal is not repeated and not persistent, if it's not seen by other observers, clearly It must be something that is internal noise, external noise, a satellite that is passing over, reconnaissance aircraft, U-2, or something like that. And it was never discussed the possibility that in reality it was something that was going very fast, and it was staying inside the lobe of the antenna only for a short time. Okay, so we have to investigate also this possibility that is something very close has entered inside our solar system. This is very possible. It could be something that is active. It could be something that is a relic, like for instance Oumuamua, like Professor Avi Loeb has proposed as a possibility, not a reality, but a possibility that must be investigated in future events. We have to be more careful. We have to be rigorous, absolutely, especially in this kind of research. But we have also to try to dare and to make a key project being able to uh, monitor the sky more carefully with key projects very well funded, because this is something very important for our knowledge. So we have to design an automatic strategy to scan the sky with mechanical parabolas telescope, or using the new technology of square kilometer array that could help us to obtain several results. In that case, we would if we have 2 points, we obtain trajectory. And once we have the trajectory, we can give the coordinates of the orbit to other instruments, to the Webb Space Telescope, to every kind of telescope, including optical telescopes, with which we could go in depth, making high resolution spectroscopy, magnetometry, photopolarimetry. We would concentrate in the astrophysical analysis of this kind of object once we are able to track them accurately. Okay, so this is not a question of corridor chatters, of gossip. Oh, he is searching for extraterrestrial or something. This is something very natural that we have to expect sooner or later. And we have to clearly also make a key project to analyze a database of IRAS, ISO, Spitzer, and soon also the Webb Space Telescope, which is an infrared telescope per excellence. So interstellar migration is possible. Interstellar migration is not a job of fantasy, but it has been published mathematically already 30, 40 years ago. Inside an infrared database, we could find something very important if we try to select what we want to search for. Okay, so not only star forming regions, which is very important clearly, but to try to select the data very carefully to see if there are some infrared excess in some G-type stars that could be important for our study. I stress the fact that this research, this proposal, is astrophysical. It's simply a kind of astrophysical research. It's not astrobiological, it's bioastronomical, I would say. And I wish that in the very short future, this research can be done. After all, after seeing what NASA is doing, studying UAPs, uh, astronomy opens just a bit. It's not a question to be open-minded. It's only a question to take out the glasses and put different lenses, okay? To This is standard physics. It's not exotic physics. So I published also about this, and also in the past I published on an important book of Springer directed by Professor Joseph Sackbach, the possibility that some of these possible, how to say, probes, if they are in the space, in the solar system, might have released sort of shuttles that have reached Earth. How would we do then? What kind of measurements would we do? Well, I've been studying for 20 years this kind of objects in the sky as an astronomer, not as an ufologist. And I'm studying right now, um, uh, especially thanks to Professor Avi Loeb, who has launched a very rigorous project, which I admire, and uh, which I wish all the best for our knowledge. And so I think I said all what I wanted to say. So I'm ready for questions.
Thank you very much. A very thought-provoking talk. So, given your idea of using searching the infrared and for variability that would be indication of these Dyson spheres, is the James Webb Telescope going to just inherently collect data that you can search through, or would you have to have special searching by the James Webb Telescope to do that, or is it just possible to once as the data come in from James Webb that it would be feasible to search through that data for those signatures?
I think it should be because the James Webb Telescope is working in the near infrared and in the mid infrared, which could be useful to us. We should couple this research also with the Spitzer telescope. Well, we should push also to the far infrared. I don't know which space telescope infrared other space telescope is in orbit. But this research should be done parallel with infrared telescope and also Webb Space Telescope because it's very sensitive in the infrared and powerful optical telescope like the Very Large Telescope that is in construction and others, 30 meters telescope, for instance, to work together. So, because it would be both optical and infrared. So, yes, I think the Webb Space Telescope can give a contribution, at least in 2/3 of the infrared spectrum.
Thank you. All right, we have a question from one of our other speakers here. You mentioned 16 G dwarfs with IR excess. Have these been followed up, and do we know more about these stars?
Well, it seems not. It seems that this research has been quite much disregarded, but I cannot exclude that this is due to my ignorance. The Fermi Lab work was something that, in my knowledge, was not coming from astronomer but from a nuclear physicist. I have all respect. I didn't. I went through internet to see if there was any follow up, but I didn't find them. But it might be my inability to search well. If something had been found, I'm sure it would have been very huge, um, popular announcement. I didn't find that yet.
I would like to follow up again. This is outside my own domain, but I'll ask a naive question. Maybe others would have a similar thing. So, um, you make a good case for you, in essence, want to have a viewfinder before you start aiming your other SETI telescopes. But would not the amount of technical sophistication of a civilization to create these Dyson spheres have to be so much more advanced than our own technical capabilities that we would still expect to see things like radio signals before we would find evidence for these Dyson spheres?
Well, civilization that are able to tap the energy of their sun are clearly much more advanced than us of thousands and thousands of years. And Probably they are not using radio waves anymore for communication, but they might use radio waves, not use radio waves, but the radio waves might be a consequence of some propulsion system. For instance, I don't know, some propulsion system that are using a synchrotron effect would produce a radio signal, something that cannot be created by natural effect. It could be something that is not a communication signal, or it could be something that people continue to use for communicate. We have no idea about that. Clearly, I would like very much that something new is invented to communicate, but I have no idea.
Okay, and I guess following up on that, Beatrice asked why using radio SETI to follow up on a candidate if 60 years of radio searches have not led to a single candidate. Isn't there an alternative way of confirming a candidate?
Well, I have to tell something. Uh, mm, it's true that Radio SETI, I've been working in Radio SETI, didn't furnish any real result. But it's also true that the data that have been got um, have not been selected very carefully. For instance, there is a protocol with SETI which is very rigid in the sense that the signal must be persistent, the signal must be constant, the signal must be seen by many other um, observatories and not only one. And above all, it must be persistent. We never found a persistent signal, so Dr. Villarol is right in telling this. But there were short-lasting signals that were not considered. We thought that they were due to internal noise, to external noise, or something, and probably it was. In some cases, it was a certain. It was a U2, um, how to say, um, reconnaissance aircraft. But in other cases, uh, there was no ascertainment that this was due in reality by something that was emitting real radio signals that was going very fast and by chance passed inside the lobe of the antenna and went away because the proper motion was extremely fast. So they didn't try to catch it again. Okay, they couldn't make some monitoring in that direction to see if you catch again. If we only had only 1 point more, we would have had the orbit and we would have tracked it like a comet and obtained fantastic signals. So it's true that according to the SETI protocol, nothing has been found. But it's also true that maybe something have been disregarded by a too rigid, rigorous, but too rigid protocol. This is my opinion, at least.
All right, well, time's about up. I'm going to take this one last question for Mark Rodinger. Given the search space of potential objects, local versus distant, and other factors, what types of anomalous observations do you think are more promising? I.e., if you had to prioritize, which one deserves more focus?
Well, yes, good question. And well, I would study more the fast radio bursts that are being observed more and more, and some kind also of gamma ray burst. Gamma ray burst are high energy phenomena that are often seen in other galaxies, and in some cases it could be the result of nuclear quakes and neutron stars or hypernova explosion, 100 solar masses. But in other cases, could be something else. There are people who did publication in the past telling that gamma ray burst could be the turning on of a annihilation engine um, from a possible, let's call it a spacecraft that is where the propeller is aligned along our line of sight. So we should a bit study better for instance, the light curve of gamma ray burst, study better the fast radio burst, other anomalies. Well, why not studying the moon? We have something very close, and we have a phenomenon which is called um, transient TLP, transient lunar phenomena. There are something strange light phenomena that are seen on the moon that could be light or dark phenomena. And with a simple telescope of celestron type, we could monitor, could make a quick project to study not only the light curve, but also take spectra of that phenomenology without any need to speak about rolling stones. This is funny theory of rolling stones that are reflecting the light of the sun. It's absolutely funny. There are skeptical theories that are not something that seems said by nutters or something. We should study more the TLP, and we don't need super telescopes, but only small telescope. And I'm wondering why key project has not been done in that case. So there is a lot on anomalies out of Earth that can be done. These are the only one that came to my mind for now.
So thank you all for your
Thank you very much.
attention, and thank you very much, Massimo.
Thank you very much.